Hello class, this is a video tutorial on graphing combined functions part 3. In this video, we'll be applying the same procedures that we've seen in the sum of two functions and the difference of two functions, but now we're going to be using it for the product of two functions. So I've tried to keep everything in the same table of values here, as we might normally try to. However, as you can quickly see, these numbers, negative 240, negative 60, and especially these ones here, we get 0, 6, 0, 0, 0, negative 30, negative 144. These don't help us at all. We could extend this and get, let's say, halves, like here, 1.5, 0.5, negative 1.5, negative 0.5, and so on. But that's just more work than we normally would need. So you'll quickly find that when it comes to the product of two functions, doing a table of values like this is not helpful at all. So I would advise to go straight into just using the features of the functions and applying the, guidelines or rules for the product of two functions. Okay, so we can accurately graph these. So p of x is equal to f of x times g of x. And here are the few rules that we're going to be applying to quickly sketch this out. So when f of x is 0 or g of x is 0, its product must also be 0. Because 0 times anything, well, that will be 0. Likewise, anything times 0 is also going to be 0. So the easiest things to find for the product of two functions is the zeros, or the x-intercepts. We can quickly find those. X-intercept here, 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 and here. So we're finished the first point. When when f of x or g of x is equal to 1, the product is g of x or f of x. So, for example, if f is 1, the product is going to be g. So let's say 1 times anything, well, it's just going to be that same anything, right? So I'll demonstrate to you that here. Let's take a look at y is equal to 1. That line there, y is equal to 1. So when f is 1, the product is going to be g. So it's going to pass through this point here. Likewise here, when f is 1, the product is going to be, let me zoom in a little bit more. It's going to be there. And last one, when f is 1, its product is going to be wherever g is. Likewise, when g is 1, its product is going to be where f is, which in this case is going to be 0. Okay, so let me just do a little bit more logic for this one to make a little bit more sense of it. Here, f is 1. 1 times whatever g is at this point, well, it's going to be g, hence why it stays where it is. And I just applied that for all the other points. So we're finished with the second point. This third point here, when f or g is negative 1, it becomes, it should have been negative. Should we switch it around? Its product is the negative of the other function. So I'll demonstrate to you what I mean. Let's say f is negative 1 times, let's say in this example that I'm giving, g is 3. Well, the product of negative 1 and 3 is going to be negative 3. So it's the same value with a different sign. So when f is -1, it becomes the opposite sign of g. In the exact same way, if g is -1, so let's say g is -1, and it's multiplying by -5, well, it becomes the same number of opposite sign. So let me demonstrate to you what this would look like in the graph. So y is equal to -1 is here. So when f is -1, so the value of g at this point, let's say it's looks to be about 3 point something, that value will be the same number but with the opposite sign. What this would mean in terms of the point is, if it has some height, let's say this height here looks to be about 3.2, don't know what it exactly is, let's say it's about 3.2. Since it's multiplying by -1, it would become -3.2. So graphically it would be the same height, so the same length here, but now instead of being above the x-axis, it will now be below the x-axis, like so. Oops. Hopefully that made some, logical sense for you. Another one would be here. When f is -1, g at this point, so let's find the height of g at this point, so it looks to be about there. It will be the same height, let's say that looks to be about 0.8. It will then become -0.8. So it would be the same, I guess, stick length or height length, but now it's going to be below the x-axis. So it would be here. Another point would be, well, this one's a lot harder. When f is -1, g at this point, we take the same height, but now instead of being below the x-axis, so once again I'll just demonstrate using numbers, this looks to be about -0.9. Because it's multiplying by -1, it would become the same height, but now it's going to be above the x-axis. So the point is going to be from here to here. Right. Oh, actually no, we missed one more. It works the same for when g is -1, so g is -1 here. Whatever, actually no, this is not going to work because it's going to be 0 anyway. So -1 times 0 is going to be 0. So that 0, I guess, is a more dominant rule in this case. Hopefully you can already see the function being drawn out for us here. So here we go, we're finished with this one. And lastly, these two are pretty much what you should already know, but now we're going to look at it graphically. If f and g have equal signs, so they're both positive or both negative, the product has to be greater than 0. So for example, if it was +2 times +3, +6. Even if it were the same sign, so -2 and -3, it would still be +6. Graphically, what this means is these points here, because they're both, so take a look, f is positive here and g is also positive. That means all the points would be positive somewhere here. Likewise, from here to here, g is negative and f is negative here. So take a look, negative times negative, it would be positive. So between 1 and 2, it would be positive like so, because negative g times negative f would be a positive product. The times when they would be different would be here. Take a look. What I'm highlighting here, f is negative, but g is positive. Positive times negative, it would be a negative product. So all in all, using that, we can, well, hopefully you can see and visualize that it looks something like so. Whoops. Ooh, probably not as much. Actually, we can see what it would be and how high would it go by just doing a little bit more. So take a look at these 2 points. This looks to be about 2.1 times, or 2.2 times 3.3. So 2.2 times 3.3. It's about 7.26. So it's very high up. So at this point, when we multiply them, it would be all the way up here somewhere. So let's try and get the scaling a little bit correct. There we are. Doesn't have to be perfect, but I hope you get the idea of what I just did there. I kind of just used some points to approximate what it would look like. Likewise, this point here looks to be about 0.5. So that is 0.5 in G. This looks to be about 2. Let's just approximate it to be 2 at this point. So 0.5 times negative 2, that's going to be negative 1. So at this point, let me highlight it again. At this x value, it's negative 2 times half, which would become 1. So 1. So from the looks of it, it looks to be about something like this. And lastly, they're both negative at this point. So negative g and negative f. So it would be positive at that point. So between these 2 points, it would be positive like so. And then from here, it would just continue off to be negative. Likewise with this one, like so. And that there is the product of f and g. This is just a basic sketch of what it might look like. And yeah, hopefully that gave you an insight into how we might use the features of the graph, and as well as these rules here to sketch the product of 2 functions. Hope to see you in the next video. Best of luck.